Hello everybody, today we will study active packaging technology. In the earlier class, we studied modified atmosphere packaging. Now, today we will see another part of the modification of the packaging environment or environment inside the packaging or environment inside the storage facility. So, active packaging changes the condition of the packed food to extend the shelf life or to improve safety or sensory properties while maintaining the quality. All active packaging technologies involve some physical, chemical or biological action for altering the interactions between the package, the product and the package headspace to achieve certain desired outcomes. In this slide, just you can see in the top portion of this slide, we have shown you how the gas movement inside the material, inside the package takes place. In the active packaging, as I narrated in the earlier class also, in the last class, while we studying modified atmosphere packaging, that the modification of atmosphere in modified atmospheric packaging is basically because of the natural process, that is interplay between the food product as well as vapor transmission and other transmission properties of the packaging material. But here in the case of active packaging, basically we try to use some active agents to get the desired concentration of gases or to manipulate the gaseous composition inside the package to the desired level. So, like different absorbers or emitters are used in this case, maybe ethylene absorber, carbon dioxide absorber or moisture absorber, whatever, depending upon the type of the food material, its respiration rates, its transpiration rates, etc. We calculate the amount of these absorbers or emitters required and put these material, these absorbers or emitters in the required quantity inside the package and which help in maintaining the desired gaseous composition. Like you can see here in this, that is the ethylene. Ethylene is consumed by the food materials or fruits, etc. It is a ripening hormone or it also releases the ethylene. So, ethylene absorber may help in controlling the ethylene concentration in the packet, therefore, to control the ripening process. Similarly, CO2 absorbent or water absorbent, they can move in and out from their respective package to the fruit or vice versa. So, ethylene, for example, potassium permanganate is used as a potassium permanganate is used as a ethylene absorbent. So, when it is put, the ethylene reacts with KMnO4 and gets MnO2, KOH and carbon dioxide. So, if you use ethylene absorbent, the chemical reaction shows that the concentration of carbon dioxide will also be increased. So, maybe that carbon dioxide scrubbers, carbon dioxide absorbers also might be required to be used. So, soda lime or many other such carbon dioxide absorbers are there, which you will see in the other slides. So, they can be used. So, when soda lime is used, calcium hydroxide, it reacts with carbon dioxide and gives calcium carbonate and water. Similarly, moisture absorbent, silica gel or many other moisture absorbers are there which can be used. Silica gel, actually it is a physical adsorption process. So, by now I think these things are clear, that is inside the package, active packaging, certain active components may be active scavenging systems which we call absorbers, or active releasing systems such as emitters, or controlled release system, maybe antimicrobials, etc. are used. You can see here in this packet, like there is in bread, to control the humidity or to control the atmosphere, these sachets containing moisture absorbers, etc. are used. So, depending upon that what we want actually, whether we want to increase the shelf life, or we want to increase the ripening rate, or we want to reduce the ripening time, or you want to that control microorganisms, etc. Depending upon the desired effect and the effect needed, we accordingly select the relevant releasers or relevant emitters and put in the towards the last of this lecture. I will take some example and tell you how to calculate the required amount of emitters or absorbers for the desired functions. So, before that, let us see, let us elaborate briefly the different absorbers. So, first of all, moisture absorbers. You all know that moisture control is required to prevent the condensation when the fresh horticultural produce respires. Otherwise, if it condenses, so the condensed moisture may provide vector for microbial or fungal attacks, etc., and the commodity may spoil soon. So, the moisture control inside the package or storage facility should be precisely regulated, but at the same time care should be taken that it should not excessively lose moisture material. Excessive moisture loss can lead to the shrinkage and toughening of the texture of the material. And in the modified atmosphere packaging, as I was telling, that the moisture control is done by natural interplay between the permeability of the packaging material and food, which is a time taking process. So, in active packaging, this process of obtainment of the optimum moisture is hastened by using moisture controlling sachets or films containing moisture absorbers. Desiccants are being used successfully for the active packaging of a wide range of food materials such as cheese, meats, chips, nuts, candies, gums and spices, etc. Oxygen absorbers or scavengers is another important aspect. Oxygen concentration can be lowered down by vacuum packaging, as we have studied in the last class in the MAP. That is, vacuum packaging can be used, or even gas flushing, etc. can be used, but again these technologies are often slow and imprecise. So, the process of eliminating oxygen from the package can be enhanced by the addition of oxygen scavengers, and these oxygen scavengers perform their activities. Normally the oxidation takes place, oxidation of the scavenger, for example iron compounds, iron powder, ascorbic acid, photosensitive dyes, etc. when they are used, they may get oxidized, and in the process they absorb oxygen, that is, they use the oxygen of the environment for the oxidation of these compounds. Also enzymes like glucose oxidase and ethanol oxidase, unsaturated fatty acids like oleic acid, linoleic acid, linolenic acid, rice extract, etc. they are used for the control of our absorption of oxygen. In fact, these scavengers, depending upon the type of the food or depending upon the other conditions that are prevailing inside the storage facility, they can reduce the oxygen content to as low as 0.01%. Here in this slide just I have shown you how the iron compound, the iron powder, how it oxidizes. Like the ferrous salts or iron powders, they react with the water that is provided by the food to produce reaction that moisturizes the iron metal in the product packaging and irreversibly converts it to a stable oxide. So, the iron powder is contained within a small oxygen permeable bag to prevent its contact with the food. So, in some sort of bag that is which has a good oxygen permeability, these iron powders are packed and that packet is kept inside the food package. Similarly, carbon dioxide releasers or carbon dioxide absorbers are also important. The carbon dioxide produced during the respiration of the gas etc. is to be removed from the package to avoid deterioration of the food, right, for such as carbon dioxide injury and or package destruction. Required amount of carbon dioxide absorbers or releasers such as hydrated lime, activated charcoal, magnesium oxide etc. can be used to maintain required CO2. These oxygen absorbers or CO2 generators are mainly used in products where the package volume and the appearance of the product which is packed inside the packet are the important considerations. For example, in the case of peanuts or potato chips etc., snack food products have been the main target for these dual action like oxygen scavenger or CO2 emitter sachets and labels. Similarly, ethylene absorbers, depending upon if you want to hasten the ripening process, one has to have ethylene emitters. If you want to control the ripening process, extend the shelf life of the fruits, ethylene absorbers can be put into the packaging material or package inside. So, a lot of ethylene absorbing substances are reported like KMNO4 which oxidizes ethylene to acetate and ethanol. So, and products based on KMNO4 cannot be integrated into the food contact materials. They are generally supplied in form of sachets because KMNO4 is sometimes toxic and it has a purple color. So, it may influence the color of the food material, it may provide some toxicity to the. So, the care is taken, that is the packet in which these ethylene absorbers are put, they should be providing required permeability to ethylene, but they should definitely stop the contact of the food with the carbon, that is potassium permanganate. Charcoal containing PDCl as a metal catalyst is effective in reducing the rate of softening in kiwi fruit and banana. It is also effective in reducing chlorophyll losses in spinach leaf, but it is not that much effective in broccoli. Flavor and odor releasers or absorbers are required to be added because the odor and flavor absorbers, they can remove the undesirable flavor substances that might be produced due to various oxidative and biochemical processes occurring in the food. By the removal of such undesirable flavor compounds, acceptability of the food material can be improved. Two types of taints, that is amines and aldehydes, are generally they can be easily removed by the active packaging. Various acidic compounds can neutralize unpleasant smelling alkaline volatile such as trimethylamine etc. Our flavor and odor scavengers have been utilized for debittering of citrus fruit juices or grape juices etc. If we take the example of grape juice, we find that the cause of the development of bitter taste in the grape juice is mainly to compound that is naringin and limonene. Limonene is formed as a result of heat treatment of the juice. When the juice is exposed to heat during its concentration, thermal processing or such other processes, then heat and also the acidity or other chemical action, acidic medium chemical action results into the formation of limonene. So, an active thin cellulose acetate layer is applied inside the packaging material for the removal of the limonene. This layer consists of certain fungal enzymes which is called naringinase, and this naringinase it has alpha aminosidase or beta galactosidase. So, these enzymes hydrolyze naringin to naringenin and purine, and both these naringenin and purines are non-bitter compounds. They are flavoring compounds, but non-bitter compounds. So, this is how the developed or undesirable example of undesirable bitterness how can be removed. Similarly, preservatives are antimicrobial releases. Many a times to control the growth of undesirable microorganisms in foods, antimicrobials such as niacin, pimeracin, etc. are incorporated in or coated into the food packaging materials. Antimicrobial packaging helps to extend the lag phase of the microbial growth, or it reduces the growth rate of microorganisms, resulting into the prolonged shelf life and better food safety. Antimicrobial active packaging film releases the antimicrobial agent onto the food in a controlled way and maintains its concentration on the food surface above the minimum inhibitory concentration for the target microorganisms, and in that way, that is the microorganism particularly which are present on the surface of the food material, they are not able to grow or multiply. On the basis of the localization of the antimicrobial compound, these antimicrobial active packaging systems may be grouped into different categories, classified into 4 groups. That is, in one group the antimicrobial is released to the package head space to interact with the product surface. In other case, the antimicrobial compound is included in the packaging material and is released to the product through migration. Another case may be where the antimicrobial compound is immobilized in the package surface, and otherwise in another case the package material has inherent antimicrobial activity. So, either of these case may be true, but the fact is that this antimicrobial agents are provided by there is a continuous interaction between the surface of the food as well as the surface of the packaging material, and its antimicrobial agent do not allow the microorganism to grow. They are applied mostly to products like meat, fish, bakery products, cheese. However, there are not many examples of use of this antimicrobial coated films, etc. for packaging of fruits and vegetables. Another very important aspect of active packaging is temperature control packaging. That is, one suitable approach is to prevent the temperature changes, because during transportation or during storage, if there are temperature fluctuations, this fluctuation in temperature may result into the quality loss or other. So, these temperature control, either the self heating packaging or self cooling packaging is used. In the picture you can see that, and they are commercially available. That is, whether they can lower down the temperature inside the package or they can increase the temperature inside the package, as the case may be. So, self heating containers and cans, like for example self heating aluminum and steel cans and containers which are used for coffee, tea and ready meals, etc. They are commercially available, you can see in the picture here. So, these containers, such type of containers, they basically use exothermic reactions. For example, the lime and water, they are positioned in the base of the container, and when you put some food material, when this lime and when this lime and water, when they come in contact with each other, the reaction, exothermic reaction takes place and heat is generated. On the other hand, self cooling cans use endothermic reactions such as dissolution of ammonium nitrate and chloride in water, which takes heat from the product and ultimately cools the product. Humidity regulators and absorbers are other very important aspect to prevent the condensation. So, moisture absorbers or humidity regulators are accordingly manufactured either in the form of sachets, pads, sheets or blankets. Moisture absorber sachets are generally used for humidity control in packaged dried foods, whereas moisture drip absorbent pads, sheets and blankets are used for liquid control, that is the food which have high water activity like fruits, vegetable, meat, fish, poultry, etc. Absorber papers and desiccant pads are used to wrap one or more fruits together. So the absorbers are basically made of two layers of a microporous non-woven plastic film such as polypropylene or polyethylene, and some super absorbents polymers are put into it. These super absorbents, they are placed between the layers and they can absorb moisture even up to 500 times of their own weight. Polyacrylate salts, CMC and starch copolymers are typically used super absorbers. They have a very long affinity for water, very strong affinity for the water. There are various types of moisture scavengers such as silica gel, calcium oxide, calcium chloride and modified starch, etc., which can modify package humidity. Microporous sachets of desiccant inorganic salts such as sodium chloride are reported to be used for the distribution of tomatoes, etc., in several cases. So after having discussion on this, another important thing is the selection of scavenger or emitters, and certain factors need to be taken into consideration, right, while selecting the absorbers or emitters or releasers for a food package. And these factors include size and weight of the product, the temperature and relative humidity to which the food will be exposed after packaging, permeability, that is the water vapor permeability or gas transmission rate, etc., of the packaging material, water activity of the product, sensitivity of the scrubber and product to moisture, absorption capacity and kinetics of the scrubber, and the desired shelf life of the product. So these are the important considerations which one should look into while selecting a suitable absorbent or releasers, emitters. So I will take up now one case study and give you an example. This is on the basis of the work done in my laboratory, where we have optimized and simulated active packaging conditions for fruits like banana, guava, etc. So I will give you that banana active packaging for banana here. That one important aspect, as I told you, the transpiration rate. That is we should model properly the rate of the transpiration. So actually the loss, that is transpiration. In transpiration there is a loss of water, right? That is when the product is placed inside the atmospheric atmosphere. If there is a humidity difference gradient inside the package and outside the package, then there will be transpiration of the water will be evaporated from the food surface through the cuticle, lenticles, stomata, etc. So the transpiration rate is dependent upon the temperature, relative humidity, storage time. In this picture you see we have our results on the transpiration rate of the banana, which is stored at different relative humidity from 70 to 90% and temperature at 10 degrees Celsius. And you can see in the figure how the transpiration rate varies with the relative humidity as well as with the storage time. So one can keep the materials. In the next slide we will show you that transpiration rate, how they can be measured. That is freshly harvested materials they can be put after, of course, after sorting, weighing, etc., then washed, and it is packaged and kept into a suitable environment or controlled humidity, and the weight loss at a regular interval is taken, and this weight loss data is used to calculate the transpiration rate. So there are a few models for the calculation of the transpiration rate which are suggested in the literature. The model are based on the mass transfer, that is the weight loss, or one can also calculate the transpiration rate on the basis of the energy balance TR, and these are the equations one can do that. So, but these transpiration rate measurement is very, very important. As I told you earlier also, here you can see this is our result. There is a package, one package where there was a humidity gradient inside and outside the packet, and it resulted into condensation of the moisture. In another case where the modified atmosphere packet was properly designed, there was no humidity gradient, there is no condensation of the moisture. So, this proper study of the transpiration rate helps to quantify the rate of water evaporation from the fruit surface, and also it helps to determine the water vapor transmission rate required for the packaging of the fruit. So, we conduct experiment, we can measure the transpiration rate, and these data, the transpiration rate data, can be used to calculate the moisture absorbers required using this formula, that is moisture absorbers in gram is equal to TR multiplied by M minus WVTR multiplied by A divided by AC. Similarly, that required mass of ethylene scrubbers required to be kept inside the MAP can be calculated by the equation RE multiplied by M divided by ACE, and where these values ACE, M, TR, WP, TR, they can be experimentally measured. Right. The TR is the rate of water vapor evaporated per kg of fruit. Then WVTR can be used like if you have that areas or vapor, the water vapor transfer rate of the selected packaging film. AC is the absorption capacity of silica gel, that is gram water vapor per gram of the silica gel. This RE is the ethylene generation rate, mole per kg per hour. ACE is the absorption capacity of KMnO4 as ethylene absorbent. So, from these data can be measured from the experimentally, or you can take from the literature, and accordingly one can calculate. So, depending upon the type of fruits and vegetable, what will be the moisture absorbers required, what will be the ethylene scavengers required, and accordingly even one can calculate carbon dioxide releasers or oxygen scavengers depending upon the permeability of the packaging material, temperature and other factors. So, we have published this data, that is we have given this model that rate of O2 consumption, rate of CO2 evolution and transmission rate for the banana can be calculated, that is using these equations, that is OTR, CTR and WBTR required for the packaging of guava and banana. All these we have provided these equations and data is available. So, once you have these data, it becomes easier. For example, now what is the water vapor that is the would condense inside the packaging film only, as I told you, when the water vapor transmission rate of the available film, that is WVTR available, is lower than the WVTR required. So, you need a specific WVTR inside the packaging material, WVTR of the packaging film to maintain that humidity or to allow the interchange of the water vapor from inside to outside or outside to inside, so that the humidity is equilibrated, humidity is maintained. So, Suppose by your experimental you found that what is WBTR available. If it is less than the WBTR R, obviously there will be. So, you have to calculate and you have to add some moisture absorbers, because whatever moisture more is there inside the package, that has to be absorbed by the moisture absorber. So, the moisture M water vapor scavenger. So, moisture scavengers required can be calculated from the formula WBTR minus WBTR R, that is the WBTR required minus WBTR available multiplied by AF divided by AC. So, AF is the surface area of the film in square meter, where AC is the absorption capacity gram water vapor per gram of the scavenger. So, in this way one can calculate the how much amount of how many grams or how many kilograms, depending upon the size of the packet, depending upon the other condition, depending upon the transmission rate, that is water vapor water scavengers, water vapor scavengers, or similarly other calculations can be made to decide the quantity of ethylene scavengers, quantity of oxygen scavengers, flavor scavengers, absorbers, etc., and they can be put inside the package. So, this is the accordingly methodology of the active packaging. So, important, that is you need to material which one wants to pack using standard procedures. It has to be washed, graded, and then the next aspect is while you does it, you should have a packaging film, that is the proper selection of the packaging film should be made, PVC, PPC, PVC film, polypropylene, whatever films are there, and one should know what is the permeability of all these films, gas permeability, water permeability. So, accordingly there is the depending upon the permeability, depend of the material, depending upon the food, fruits, vegetables, etc., you need to select the scavenger, and these scavengers, like they may be for moisture scrubber, for other scrubbers, they to be put into the some sort of sachet, or they come in the form of film, in the form of sachet, in the form. So, this should also be packed, and it is kept inside the package, calculated amount for the amount is stored or for the required effect needed. So, with this I thank you. By now I hope you have got a good idea about what the modified atmosphere packaging is there, what is active packaging. As I will again like to say that major difference in that, in modified atmosphere it is the natural process which controls the atmosphere inside the package. In the active packaging we include, that is we hasten the control process either by putting active scavengers or emitters or releasing systems, and this ultimately helps in improving the shelf life, in improving the quality, in reducing the microbial load, and so on. Thank you.